Alright, so there's a few things that we start this review that we did not go into as much depth about. And so I kind of want to describe the difference in some things that we haven't really seen and some things that we have. We have looked at evaluating functions, f of 4, and this is a scenario where we wouldn't do much more than take the function that we're given, f of x, and we're going to plug in 4 for x and evaluate. So I'm kind of talking about problem number 1. There are some other things, however, that we haven't seen as much of. So we haven't seen 3 times g of x, or at least we didn't work examples like this, which is kind of why I want to talk it over. So in this case, we would multiply by 3 on the outside times g of 6, which would be 6 squared plus 3. So 3 stays on the outside, and we're going to end up with 36 plus 3, which is 39, and our final answer is going to be the product of 3 times 39. Okay. All right, we've seen things like f of x plus 2. Another thing that we have not really looked at is problem number 4. And again, this is we don't need to overcomplicate this, which is part of the reason why I put it off, expecting to be here today. But really, we're just adding these functions. So this is this represents f of x plus g of x. So our f of x function is 3x minus 1, and our g of x function is, so we're adding, is x squared plus 3, and all we're going to do is add these two things together. So since we're adding, we can kind of drop the parentheses. We're not distributing. Again, this is not multiplication, and we're just going to rearrange this thing in order and combine like terms where we can. In this case, there's not too many that we can add. It's going to be x squared plus 3x plus 2, and that's as far as we can go. We're not solving because there is no equal sign. And so I wanted to talk about this in hopes that you would kind of see the pattern if we are subtracting. Our g of x will go first, and so we'll say x squared plus 3 minus our f of x, which is 3x minus 1. In this case, we do need to distribute the negative sign, so we'll have x squared plus 3 minus 3x. When we distribute this here, we end up with plus 1. And so x squared minus 3x plus 4. The final example I kind of want to talk about, or example of things, so let me rephrase. I'm going to go over at least 2 more. I do want you to recognize the difference in problem number 6, the difference in closed dot, which would represent multiplication. I want to highlight that right here, versus the problems below that we have seen, which look like this. Okay, when we have this open dot, this circle, this represents f of g of x, where if we have this, it's going to represent f of x times g of x. So we'll be multiplying in this case. Alright, so let me work a few of these, a couple more of these examples, and I'll turn you free to work on this on your own. Alright, so in this case, f of x is 3x minus 1, and g of x is x squared plus 3. So we would simply distribute 3 through here. We're going to end up with 3x to the third, outer, so plus 9x, inner, minus x squared, minus 3. I will leave you to the step to kind of rearrange that, combine like terms if there are any, or at least put it in standard form. And then problem number 7, let's look at one where we are dividing. So this would be 3x minus 1 over x squared plus 3. And so this kind of leads us to the second point that I'm going to make on this review, which is looking for any restrictions in the domain. Okay, and again, we're going to look at some more of these down below as I kind of work through just a couple. But we are asking ourselves, we know that the denominator, this down here, cannot be equal to 0. So what would x have to be in order for it to be equal to 0? So in this case, x squared plus 3, we're saying cannot be equal to 0. So if we solve this like an equation, x squared is equal to negative 3. We could take square root. We could say x cannot be equal to I root 3. Really, we should say positive. Really, we should say positive or negative I root 3. And again, that's just finding things in the denominator. Whenever there's a variable in the denominator, we have to make sure that we say that variable cannot be equal to the value that would make the denominator 0. Alright, with that, let me see if there are any others. Notice on problems 10 and 12, that is not multiplication, that is g of f of negative 1 and f of g of x. Alright, let me see which one I wanted to talk about. In this case, I wanted to talk about number 15. Sorry, not number 15. Let's skip down. We're going to look at 21, 22, and probably 24. Those are the ones that I want us to look at. Alright, so moving along with those. Problem 21. Let's evaluate. We have f over f divided by g, which is going to be f of x divided by g of x. So in this case, f of x, we're going to end up with 2x squared plus 5x minus 12, that's my f of x, over g of x, which is x plus 4. So what I wanted to, the point that I want to make is at this point we can already tell what restrictions or a potential restriction with our denominator. Anytime an x value shows up in the denominator at any point, it is going to be listed as a restriction. Okay, so we can already say right now that x cannot be equal to negative 4 because that would make the denominator 0. But we are going to look to see if this can cancel. And so some things that I want to remind you guys are we need to simplify some things. So before we, I guess, kind of turn in our final answer, I need you all to check to see if this can be factored. If it can be factored, you need to factor it. If an x plus 4 factors out of it, then it can cancel with the denominator. Again, x equal to, or not equal to negative 4 is still part of the answer, but we need to make sure that we list that. Okay? So again, I'm not working that one all the way through, I just wanted to set it up. Okay, taking a look. I will come back to that. I'll list this down here. X cannot equal to negative 4. Looking at g over f of x, so if we change that, the same thing would be true. So we have x plus 4 over 2x squared plus 5x minus 12. This is a place where we need to really check, is this factorable? And if it is factorable, then we need to make sure that we list all of the factors or all of the solutions of those factors as restrictions, because again, x cannot equal 0. Last place that I said I wanted to look was problem 24. So g of x is x plus 4. So we are going to end up with something that looks like this. h of x plus 4, which is going to be 4 over x plus 4. This is not exactly the example that I was going for, because the point, but I feel like I've already made the point that I was going to make. The point that I was going to make is, even if our variable cancels out later on, if it shows up in the denominator at any given point, it is a restriction. Alright, that covers almost everything. Again, I'll be in early Monday morning if you want to stop by, but study over the weekend. The key will be posted this afternoon.